3 roots, it's a cube root. All right, so first of all, let's take a look at square root functions. All right, now I picked these x's very specifically because I want to use them because they're perfect squares. So for example, when I plug in x, the square root of 0 is 0. We have this point 0, 0. When I plug in 1, the square root of 1 is 1. When I plug in 4, the square root of 4 is 2. These are the first 3 perfect square numbers. I could plug in 2 and I could get a decimal, but it's just not as nice. All right, so I have that means they line up nice on these grids. All right, and you can see a square root function kind of looks like half a parabola, but it's not a full parabola because then it would not be a function. All right, the domain of this, remember how we did domain? We have our x's. What's the lowest x I could have? The lowest x I could have is 0. What's the highest? I could go on to positive infinity. So remember, we wrote that as just x is greater than 0. And our range, all right, same thing with our y's. So our lowest y on this one is 0, and our highest y is infinity. So again, y is greater than 0. All right, so that is our domain and range there. All right, so let's take a look here. We got a lot to look like. What happens when we multiply this radical by some number a? Well, let's take a look. Let's say that number is 3. So the first thing I need to do is put in 0. 0 times, the square root of 0 is 0 times 3. Oh, that doesn't change anything. Plug in a 1. The square root of 1 is 1. 1 times 3 is 3. So now I have 0, 0. I have 1, 3. All right, and the square root of 4 is 2. 2 times 3 is 6. So it's going to go 4 up to 6. So you can see right here, this really stretches it. So as the absolute value of a gets bigger, there's a vertical stretch. All right, let's take a look at what that means for a second. We'll get there in a second. Let's do this one. Half of half of radical x. So 0 again, half of 0 is 0. That's easy. Plug in 1, square root of 1 is 1. Half of that is 1/2. Plug in 4, square root of 4 is 2. Half of 2 is 1. So this would be 0, and then a half, and then over here at 4 would be 1. Now you can see here, as absolute value of a gets closer to 0, it actually shrinks in. So bigger than 1, it's going to go big. Less than 1, it's going to shrink. And we can take a look at this even better over here on our graph. All right, let's take a look. So a is 1. If I make a bigger than 1, it stretches, and it continues to stretch. And that's because it's a scalar. That number on the outside just scales it, all right? If we go towards 0, it shrinks, all right? It goes down. What happens if a is negative? Well, if a is negative, it flips, all right? So you can see all the same stuff. It's just upside down, all right? Again, remember, this is not a whole graph. This is one separate graph. This is our standard graph, and this is what what would happen if I multiply by -3, all right? All right, so let's take a look at the next thing. So when a is negative, the graph flips. So we have a couple rules here that are really important. If the absolute value of a is big, so it's going to stretch vertically. It's going to get vertically bigger. If a is less than 1, as it gets closer to 0, it's going to shrink, shrink, shrink. It's going to be less than our standard. And if a is negative, we flip it. All right, so let's take a look now. We are going to see what happens if I change something on the inside. So if I subtract a number inside the radical, let's see what happens to our graph. So right now our h is 0, so it's exactly the same graph. Let's change it to h is 2. When h is 2, so it'll be x minus 2. It moves 2 to the right. All right, let's say h is -3. -3, it moves it to the left. All right, and you can see it does exactly that. Positive numbers, it moves to the right. Negative numbers, it moves to the left. All right, let's go back to 0. What happens with this k up here? This is outside the radical. What happens if I add 5 to it? It moves vertically up. It's the exact same graph, just vertically up 5. What if I put it at -3 or -2? -2, it drops down to. All right, so we can see right now that what's happening here with our graph is we have a change inside. It's actually the opposite of what it does inside, and it's exactly what it is on the outside. So let's write these rules down. So we have down here, oh, you can't see that, it's a trick. So if we have an h on the inside, it translates the graph h units horizontally. Now remember in here, this is sometimes hard for you guys, but this is the opposite, all right? So if this is -2, it goes to the right 2. If it's, x minus 2, if it's x plus 2, right? If it's x plus 2, then it moves to the left 2. You do the opposite. And over here, when we have something on the outside, when we're adding something on the outside, what does that do for us? It translates the graph k units vertically. So it would go up k units or down. If it's positive, plus a number, so if it's plus 2, it's going to go up. If it's -3, it's going to go down. So horizontally is the opposite, and then the vertical one is exactly what it says. And this is great because this is exactly the same as vertex form for our quadratics that we've already learned this year. It's exactly the same thing, all right? You can see in our graph, we kind of have this point. It's not really called a vertex, but it's a great point of reference. It's kind of where the graph starts, and it just moves over. So if I have my h now is 4, so it's h minus 4, and then my k is plus 6. All right, you can see my graph moves over 4 and up 6, just like the ones we've done before. So let's try and graph some of these, all right? So the first thing I want to do is I want to find that reference point, that starting point. So this is -4, so that reference point is going to be at a +3, +4. So I'm going to go over 3. 1, 2, 3, up 4. 1, 2, 3, 4. All right, now, remember these points, 0, 1, and 4, and they took us to 0, 2, 0, 1, and 2, right? Well, I'm going to scale this one by 3, so I'm not going to go to 0, 1, and 3. I'm going to multiply it by 3. So I want to go over 0. I want to go, my next one, I want to go over 1, and I'm going to go up, instead of 1, I'm going to go up 3. And instead of going over up 2, I'm going to go up 6. So here we go. So I'm here. I go over 1. I'm going to go up 3. 1, 2, 3. All right. And then I go over to my 4. 1, 2, 3, 4. And then I go up 6. 1, 2, 3, 4, 5, 6. And there is my radical function. All right. Over here on this one, remember this is just another way to write x plus 2 to the -1/2. It's the same thing. So what's my reference point? It's going to be -3 is my vertical shift, and -2. So -2, 1, 2, 1, 2, 3. 1, 2, -3. All right, so let's take a look. It is scaled by a negative. So instead of 0, 1, and 2, I'm going to have 0, -1, and -2. So I'm going to go 1 over, 1 over, and then I'm going to go down 1. I'm going to go 4 over, 1, 2, 3, 4, and then go down 2. 1, 2, and there we have our radical function, our square root function. All right? All right, so now let's do cube root functions. Let's see what we have here. So I'm going to take the cube root of -1. The cube root of -1 is -1. And 0, the cube root of 0 is 0, and the cube root of 1 is 1. So I have 0, 0, I have 1, 1, and I have -1, -1. All right, now the domain, let's be honest, let's look at this. Is it ever stop going left? No. Stop going right? No. So the domain is all real numbers, which is nice. And the range is going to be the same, all real numbers, which you gotta like. All right? And you can kind of see the same pattern is going to hold through. It comes in here, and it looks, if you think about it, here's a square root function similar to that, right? and then kind of like similar to that, a little bit on that side too, right? So we have it and it's one big swoop. It almost looks like an S. So let's take a look here. Now here's the great thing. Here's our generic cube root function. Everything, all the rules are the same as with the square root function. All right? As the absolute value of a gets bigger, there is a vertical stretch. It increases by that amount. As the absolute value of a gets closer to 0, it shrinks. So it flattens out. So this one might be big vertical stretch. This one would flatten out. If a is negative, then the graph flips. So let's take a look at this. Here we go. So let's take a look at a. Right now we have a is 1, not a problem. Let's see if a is 2. Plug in 2, and you can see it is vertically, it is stretching. All right, we can stretch it even further. Ooh, 5, it's getting closer and closer to an S, right? Now let's go, so let's try a negative. What happens with if it's a negative? Negative, it goes exactly the same thing, just the opposite way. So instead of starting low and going high, it starts high and goes low. The end behavior changes, all right? The H, translate the graph H units horizontally, and again, it's the opposite. So if it says plus 5, it really means you're moving to the left 5. All right, so if it says x plus 5, the third cube root of that, you're actually moving left 5. And if it says the cube root of x minus 5, you're actually moving to the right. Just like with the quadratics, just like with the square roots. And k, up and down, just the same way. And if you don't believe me, let's take a look at the graph. So let's just make this a normal 1. Let's translate it. Let's see that this reference point here, this middle point, 0, 0, let's make it 3 and negative 4. 3, negative 4, so it shifted it 3 over, and then 4 units down, and there's that reference point. And then again, with that table, I went over 1, up 1. I went over to the left 1, down 1. All right? That's a big thing. Okay? So let's try and graph some of these. All right, so here we go. So the very first one, my reference point is going to be at positive 4 and negative 2. So 1, 2, 3, 4, 1, 2. All right. So now I remember my points 1, 0, 1. Right? So, and they were negative 1, 0, 1. So now I want to multiply that by 2. So this is going to be negative 2. So I'm going to go to the left 1, down 2. I'm going to go to the right 1, up 2. Whoops, that's not 2. Come on, Sullivan. So I'm going to go to the right 1, up 2. So it's going to look like that right there. All right? Over here, I'm going to stretch it by 3/4. So we'll get to that in a second. So the reference point is going to be negative 4 and 3. So I'm going to go 1, 2, 3, 4, 1, 2, 3. All right, so I'm going to do 3/4. So instead of negative 1, it's going to be negative 3/4. Instead of 0, well, it's still going to be 0. And then this will be positive 3/4. So I'm going to go over 1, positive 3/4. Oh, right about there. Yeah, this is an estimate, right? Left 1, 3/4. So again, we know it's going to look like an S. It's probably going to have to be a little bit flatter than that. But that's harder to do, isn't it? All right. All right, last one. This is, again, negative, and this is just cube root of x minus 4 plus 2. So our reference point's at 4, 1, 2, 3, 4, and up to 1, 2. So we're going to multiply it by negative 1. So instead of negative, I'm going to do negative 1 is going to go to 1. 0 still goes to 0. And 1 goes over to negative 1. So here we go. So 1 over, down 1. To the left 1, I go up 1. All right, it's a little bit different. It goes this way, and it goes that way. My bad. So it goes that way and that way. All right, there you have that, the domain and range. Let's take a look and go back and state the domain and range for all of these. The domain and range for all of these is what? all real numbers. All right, great thing about having the cube root, it's all real numbers. Let's go back and look at those square roots though. You need to do the domain and range for the square roots. So domain and range on this one. So domain, I want all my x's, let's see, my minimum x is 1, 2, 3. So I want all the x's greater than or equal to 3. And my range, I want all the y's greater than or equal to 1, 2, 3, 4. Over here, my domain, I want all the x's greater than -2. All the x's greater than or equal to -2. And my range, this time it's going to go down. So I want all my y's that are less than or equal to 1, 2, 3, -3. All right? So domain and range is very important. All right, so now we're going to find the equations of these, all right? So the first thing you need to understand is if it's a square root or if it's a cube root. Well, if it's a square root, it just goes one way, so we know this is going to be a square root function. Remember, the generic formula for a square root is a times x minus h plus k. So this is the opposite of what it says. So I moved this reference point from 0, 0. I moved it right twice. So this is going to be x minus 2. And then I moved it down 1, 2, 3. So minus 3 on the outside. Now the only thing we need to check out is if there's any a. So remember, for square roots, we had 0, 1, and 4. And that should be, the square root of 1 is 1 and the square root of 4 is 2. So let's check. If I go over 1, do I go up 1? Yes. If I go over 4, 1, 2, 3, 4, do I go up 2? Yes. So it matches our generic equation exactly. So in that case, there is no scalar, and we're good to go. All right? Let's take a look at our cube root function here. We know this is cube root, so I'm going to write our generic cube root function here. Well, it looks a lot like our square root function, doesn't it? So we'll call this one g of x. So the first thing I need to find is that reference point where it was the shift. It moved to the left 1, 2, 3. So that's a positive. Remember, plus 3 because I do the opposite. And I went down 1, 2, 3. So that's minus 3. Now we need to see if there's a scalar involved. And remember, -1, 0, and 1 are our reference points, and they should go -1, 0, and 1. So here we go. If I go to the right one, did I go up 1? Yes. If I went to the left one, did I go down 1? Yes. So there's no scalar on this one either. Wow, that makes it nice. All right. So let's try this one, number 8. So we know it's going to be square root because it's not the general cube root graph. I know that I go to the left 2, and so I do the opposite on the inside, so that's plus 2. And now I went up 2, and that's a plus 2 on the outside. So we need to see if our points match up with 0, 1, 4 and 0, 1, 2. So let's try it. Over 1, does it go up 1? No. It actually looks like it goes up a half. I'm just going to guess that it goes up a half. Let's see, go over 4. 1, 2, 3, 4. It went up 1. So this went up, it looked like a half, and this went up, it looked like to 1. So what's the relationship? How do I go from 1 to a half? What do I have to multiply 2 by to get to 1? I have to multiply all those by a half. So it scaled it by a half, and that is our equation. All right? So what I want you to do right now is pause the video and try these on your own. Great. So let's take a look. So we know this is a square root one, all right? So that means I'm going to start at 4 over 1, 2, 3, 4, minus 3. 1, 2, 3 right there. And we have a scalar of 2, so instead of 0, 1, and 2, I'm going to have it go to, it's going to go to 0, 2, and 4. So 1 over, up 2. 4 over, 1, 2, 3, 4 over, up 4. 1, 2, 3, 4. And there is our graph. All right, this one is a cube root. So remember our reference points. So I'm going to scale it. So it's going to be -3, 0, and 3. So let's take a look. Where does it start? Is there any shift on the inside? No. So it just goes up 4. 1, 2, 3, 4. Some of you guys freak out when there's nothing in there. All right? It just means I'm not going left to right. So now I'm going to go over to the left 1, down 3. 1, 2, 3. And to the right, 1, 2, or excuse me, 1 over, and 1, 2, 3 up. So now we know it's going to look like that and look like that. All right? This one we need to find the equation. Oh, it's a cube root. So we know it's a cube root, so let's take a look. It shifts to the right 1, 2, 3. So that's x minus 3. Does it go up or down at all? Nope, so there's no k. All right, so now let's take a look. So we want to compare to -1, 0, and 1. So if I go over 1, it looks like it goes up a half. If I go to the left 1, it looks like it goes down a half. So I'm going to say that this is 1/2 cube root of x minus 3. All right? So there you have it. And one more. We have another of my favorites all-time SNL commercials. Kill that master check one more, and then I'll see you on the flip side.